Hi, I'm going to work out a few of the problems from the non-credit review for test 2. The very first question asks you to determine the measure of the angle theta given theta is an integer and measured in radians. Before I get to the actual problem, I'm going to work out on the concept of the problems. So notice I have written the degree measures and the radian measures. So first thing, I want you to pay attention to the two important keywords. One is integer, other one is radians. So when I'm talking about radians and integer mode, it's not going to help me if I answer my question in terms of degrees. So if I have an angle, let's say shown something like this. Okay, now let's see. If my angle is shown as theta 1, which is obviously in the first quadrant, so its angle measurement will be between 0 and 90 degrees, or in terms of radians, it's between 0 and pi by 2 radians. But degree measure is not going to help me, so I will just look at pi by 2 radians. And if you divide the quantity pi, which is an irrational quantity, it will not going to be an integer value, right? So I know I should think in terms of real numbers. So if I associate real quantities with the radian measurement, I know I can write it down as 0, and this one will be let's say pi radian comes out to be my approximately 3.14 radians, and if you come halfway through, it will be 1.57 radians. Now if I look at theta 1, which was between 0 and 1.57 radians, it does come out to be theta 1 will obviously be 1 radian. Now if I mark another angle, let's say something like theta 2, okay, which is in the second quadrant just past 1.57 radians, so theta 2 will come out to be definitely 2 radians. If I had marked another angle, let's say something like theta 3, the yellow angle, so theta 3 comes out to be again in the second quadrant between 1.57 and 3.14, but if you think logically, your angle is closer to 3.14, so the radian integer value can only be 3 radians. Look at an interesting angle, which is in the fourth quadrant, and I am going to label the angle as theta 4. But if you thought this is in the fourth quadrant, which is past 4.71, so maybe your angle measurement will be 5 radians. That is not correct answer. The reason is theta 4 can only be generated. Notice every time you work on any standard angle, you know your initial ray will always be along the positive x-axis, and the terminal ray will decide the measurement of that angle. In this particular case, theta 4 can only be generated by going clockwise, so theta 4 obviously will be a negative angle, so it can go from 0 through negative 1.57 radians. So your theta 4 will come out to be negative 1 radian in this case. And if you look at the original problem, which was shown theta in the fourth quadrant, but again it can only be generated by going clockwise, so theta comes out to be -1 radian. Let me just identify the very common mistake. Let's say if I would have marked this angle to be my theta 5, okay, notice how I generated this angle by going counterclockwise, right? So that time your theta 5 definitely will be 5 radians because I went counterclockwise and it's in the fourth quadrant, which is past 4.71 radian. So your answer comes out to be 5 radians.